Good morning, everyone, and welcome to this week's CATS math video. This week I will be doing a mini lesson on proportions. Before we get started, let's go ahead and review what we learned last week. Last week, you learned what a ratio was. A ratio is a comparison between two objects or things. If you notice in the picture that I've attached, we are comparing girls to boys. And the ratio would be 5 girls to 15 boys. We also learned that there are 3 ways to write a ratio. The first way to write a ratio is the word to. The second way to write a ratio is to use a symbol called the colon. And the third way to write a ratio is to write it as a fraction. So let's go ahead and take a look at the example below. When using the colon, I'm still going to read the ratio as 4 to 1. When reading it with the word to, I would say 4 to 1. And when you write it as a fraction, I'm still going to read it as 4 to 1. So no matter how you write it, you will always read a ratio with the word to. All right, so let's go ahead and try it out and see what you remember from last week. So the first question here says, what is the ratio of girls to boys? Take a minute to write your answer all 3 ways. I'm going to give you 10 seconds. That is correct. You should have written it as 4 to 3 with the word to, 4 to 3 with a colon, and 4 to 3 as a fraction. Let's try the next one. For this example, I would like you to find the ratio of circles to total shapes. Circles to total shapes. For this one, I will give you about 15 seconds. All right, hopefully you all wrote that there were 7 circles to 14 total shapes. We should have written that with the word to, 7 to 14 with a colon, and 7 to 14 as a fraction. Good job, you all. Now let's go ahead and talk about a proportion. A proportion is an equation, so that means it needs an equal sign, stating that 2 ratios are equal. So keywords are an equation, 2 ratios, and equal. So let's take a look at the example below. In the example, you'll notice that we wrote both ratios as fractions. On the left, we have 1/2 equal to 4/8. I think this late in the school year, we would all agree that 4 is half of 8, so 4/8 is equivalent to 1/2. Therefore, this would be a proportion. A good way to think of a proportion is to think of it in real life. When something is in proportion to one another, it looks somewhat balanced. It looks even. It looks equal, I would say. So let's take a look at a real life situation using our bodies. In this first picture, you're going to notice that the young man's head is extremely larger than his body. I think you all would agree that this does not look normal. So this is an example of not proportional. In the second example, I don't know if you've ever seen the movie Beetlejuice, but this guy has a head that is much smaller than his body. I think you all would also agree that this does not look normal. So this would be not proportional. In the last picture here, this is an example of something that would look proportional. Everything appears to be the way it should. If this were a skeleton of a real life person, it looks like the head matches the shape and size of the body. So I would consider this to be proportional. If you ask me, I think being in proportion would mean being balanced. If you look at the picture of the rocks, the balance is straight, which means that both rocks are equal in mass or weight to one another. Okay? Now that we can understand that in a real life sense, let's take a look at how this applies to math. All right, boys and girls, so now that we've reviewed what a ratio is, let's go ahead and talk about what a proportion is. In the video, well, actually on the slide, you just saw that a proportion is an equation that lets you know that two ratios are equivalent. So let's go ahead and take a deeper look at what exactly this means. All right, so let's go ahead and let's take a look at something. Let's say that we have 1 to 2 equal to 4 to 8. As you can see, I actually started with the example that was on your slide. So let's take a look at what this is. 1 to 2 could look like this. 1 circle, 2 squares. Okay? 4 to 8 could look like this. 4 circles, 8 squares. Okay? So if we break this down, these are proportional, because if I were to draw a line at those spots right there, there is a 1 to 2 ratio of circles to boxes or squares in each one. So these are equivalent. One of the strategies that I'm going to be showing you today is to find your cross products. Okay? So what we would do is we are going to circle these and we're going to ask ourselves, because I said cross product, we should know that product is the answer to a multiplication problem. So 2 times 4 is 8. Now let's find the other cross product. 8 times 1 is 8. All right, take a look at these numbers right here. Our numbers are the same, so this means that both of those ratios form a proportion. Let's think about our balance. In this example, 8 would be on one side and 8 on the other side, and because they are equal, your balance will actually show straight across. Hopefully you can see that. Okay? All right, let's look at another example. Let's say that we have 3 to 9 equal to 4 to 12. In order to find out if these form a proportion, I am going to multiply and find the cross products. So again, I'm going to ask myself, what is 9 times 4? The answer is 36. Now I'm going to multiply 3 times 12, and the answer is also 36. So because the cross products are both 36, this tells me that this is a proportion. Let's think of our balance. Because we have the exact same number, this looks normal. So this is a proportion. Let's look at another example. All right, let's say that we have 1, 2, 3 equal to 5 to 4. All right, so again, we're going to check to see if this is a proportion by finding our cross products. So 3 times 5 is 15. 1 times 4 is 4. What do you all recognize about your cross products? That is correct. They are different. Because they are different, this does not form a proportion. So think about it like this. You're either going to have a small body and a big head, or that's about it. That's about what you're looking at. Okay, so let's think of the balance here. Our balance is going to look like that. 15 would be here, 4 would be up here, and if you notice, 15 is heavier than 4, so because they're not equal, they're not straight across, this is not a proportion. Okay? Let's do one more example before you get started. All right, let's say that we have 7 to 8 equal to 3 to 4. All right, the first thing we are going to do is we're going to find the cross products. 8 times 3 is 24. 7 times 4 is 28. So I'm going to ask you, is this going to form a proportion? Hopefully you said no. And if I were to ask you why, turn to your partner and say why. Hopefully you shared with your partner that this is not a proportion because the cross products are not equal. Okay, so let's think of our balance. In this case, our balance will be angled. We'll have 28 on the bottom, 24 on the top. If you notice, those are not balanced, so this does not form a proportion. All right, what you are going to get now is a series of 7 slides. Each slide will give you 2 ratios, and you have got to figure out if they form a proportion. I would like for you to use the cross product method to determine whether yes, they are a proportion, or no, they are not a proportion. Good luck, you all. So, did any of you notice that I made a mistake on that last slide? Good catch. 2 times 10 should have given you 20. I put 10. Even with Mrs. Alfaro's mistake, the answer still would have been no. All right, boys and girls. So now that we've established what a proportion is, I'm going to challenge you all to find the missing number. Okay? So let's take a look at our first example. Let's say that we have 2, 2, 3 equal to 4, 2 blank. Okay? If you'll notice, now I've given you 3 of the 4 numbers. We've got to figure out what our missing number is. So let's talk about what I just showed you. I just showed you the rule of the cross products. So let's go ahead and multiply the 2 that we have. 3 times 4 is 12. And now let's do some mental math. We know that this number right here needs to be a 12. So 2 times what number here would give me that 12? Did you say 6? I hope you said 6, because 6 times 2 is 12. So in this example, our missing number would be 6. Now let's look at an alternative method, okay? The problem that I gave you was 2, 2, 3 equals 4 to an unknown number. Another way to think about it is look at it going across, okay? There is a way we can go from 2 to 4. Has anyone seen it? Okay? We can multiply 2 times 2. 2 times 2 is 4. Now, in chapter 2, we learned all about fractions, and we know that in order to make an equivalent fraction, we're going to do the same thing to the bottom that we did to the top. So, boys and girls, what is 3 times 2? That is correct. Our answer is still 6. So we can do mental math, or we can look at how multiplication or division would apply. Okay, let's look at another example. Let's say that I give you 6 to 12 equals an unknown number to 6. Okay? All right, so let's look at our rule of cross products. We would multiply 6 times 6 and get 36. Now let's do some mental math. 12 times what number here is going to give us 36? Did you all say 3? Hopefully you said 3, because 3 would be our answer. So again, 6 times 6, 36. 12 times 3, 36. Now let's look at the alternative way. And the reason we use the alternative way is because sometimes, and sorry for the interruptions, but sometimes your numbers will become so large that it's easier just to think about basic math, okay? So again, let's look at solving it using either multiplication or division. 6 to 12 equals an unknown number to 6, okay? All right, in this case, I have both numbers on the left-hand side. Now, if you notice, we got smaller going from 12 to 6. Well, how do we go from 12 to 6? Well, it would be dividing by 2. So in order to form an equivalent ratio on the other side, we need to divide 6 by 2 as well, and that's going to give us 3. So again, strategy 1, mental math. Strategy 2, using multiplication or division to find the equivalent ratio. Let's look at one more example. All right, let's say we have an unknown number over 7 equals 4 over 14. Okay? All right, looking at the cross products, we can multiply 7 times 4, and we know that this is going to give us 28. Now let's think. 14 times what number there is also going to give us 28. What number could it be? That is correct. Your unknown number would be 2. 7 times 4 is 28. 14 times 2 is 28. All right, now let's look at the method using either multiplication or division. Okay? All right, you're going to notice that this is the side that I have a numerator and a denominator. I have both parts. Okay? Well, to go from 14 to 7, I'm going to compare the bottoms. We are going to divide 14 by 2. So in order to find an equivalent part, we need to divide the top by 2 as well. And that is going to give us an unknown number of 2. Okay? So one last time, we have using cross products to think mental math to find the unknown number, or you can use multiplication or division to find the unknown number. All right? Let's practice. All right, you all. If that was overwhelming, breathe. We will be practicing more in math class. Hope you have a great week, and I will see you again next week.